Example 1.19 says determine if the following equations can be used to represent a function. If so, define such a function. We've done some defining, but I had already previously said that the equation was a function just without the domain specified. That was in example 1.17. So with this set of problem, we don't know for certain that the equation that we're given is actually going to be a function. So we're going to have to do some investigation on that. Now, the definition of a function has a word that really sets it apart from all the other mappings, and that word was the word unique. And we were talking specifically about unique values from set B. Unique elements from set B is what we were really getting at there. So when I look at y equals x minus 4, I want to make a table to help me understand what some of the order pair are going to look like. So the first column we'll call x, second column we will call y, and we'll just start picking values. Say -3, 0, 1, I don't know, maybe 2.5, just variety of things. And we probably don't need to go real deep into this before we start to see the pattern. According to the equation, I'm always supposed to take a number and subtract 4. So I take -3, subtract 4, I get -7. 0 would then map to -4, 1 would map to -3, 2.5 would map to -1.5. So what we're looking for is a pattern that would tell us whether or not we're dealing with a function. The uniqueness says every x value is only allowed to map to one y value. And that's precisely what we have. Every x value that we picked, we only calculated one y value. Not two, but just one. That's what makes this a function. So I'm going to go ahead and state that this is a function. And I can define such a function. I'm going to use the letter f for the name of this function. If you want to use something differently, you can. Now remember, when you define your function, you also have to be thinking about what would be the domain for this. What would be the largest possible domain? More often than not, that's what you want. And that's what we'll do here. So if I think about the way the equation works, it says, again, take a number and subtract 4. And if you think about all the numbers in the world, you should be able to take any number that you want and subtract 4 from it. There's not a single real number that you can't do that with. So the largest possible domain is going to be all real numbers. These will be the values that map to other real numbers given by the equation f of x equals x minus 4. So I took out where it said y, and I replaced it with the function notation using the name that I gave this, and that was f. So that's where the y went. Y would have been right there, but I replaced it with the f of x. So let's do the same thing here with part b. With part b, I have x squared plus y squared is equal to 9. Now this equation is not quite as user-friendly at the moment for making a table. So what I would like to do is solve this for y, then I can think about making a table of values. So my first thing is to subtract x squared from both sides. That's going to give me y squared equals 9 minus x squared. And to finish getting y by itself, I will want to take the square root of both sides. So when I take the square root of both sides, I will end up with y equals plus or minus the square root of 9 minus x squared. So that's a detail that sometimes gets overlooked. When you are in an equation setting and you take the square root of both sides of your equation, you are required to include a plus or minus symbol like we have here. And this immediately should throw up a red flag. If I was to let x be equal to 0, we'll take a simple x value, and I want to plug that in. Then I'm going to have this statement, y equals plus or minus the square root of 9 minus 0 squared, which is going to become y equals plus or minus the square root of 9, which is then going to say y equals plus or minus 3. So what I'm saying is that 0 maps to 3, and 0 also maps to negative 3, which means that there's two different outputs for that one input. This violates the uniqueness criteria that a function must have. So this is not a function.